Thank you. First, I'll start off with a little bit. You can read the title, so it's a little bit different than what Keith had alluded to. And when I was kind of putting the fine touches on it, I realized that reclamation and remediation are hand in hand. So because I thought most people here would be an oil and gas background, most of the sites that we're reclaiming were a function of some sort of remediation activity, or the well site came no longer in use. So Trace Associates, we're a small company, about 65 employees. We have offices in Alberta and in Saskatchewan. So as a forester, I was originally working for Miller Western, and Miller Western as a company got involved in wet area mapping in about 1997, 98, and around there. So myself, I've always been kind of watching wet area mapping, and about a year and a half ago, actually started using wet area mapping on active sites that we were responsible for. So that's my kind of history with wet area mapping. So what I'm going to talk about today might not be exact examples that we've done, because I think that there's some client privilege type things that we've got to be aware of, but they are related to what we've learned and kind of put into action. So we'll talk about methodology, the challenges. That might not be the best word, but the criteria, the forestry criteria, that's how we'll tie everything in together here. Some case studies, what we've actually done, and then we'll follow up with a summary. So the methodology, when we look at bare ground LiDAR, I mean, this doesn't tell us anything. You know, without really zooming in and being familiar with the topography and what bare ground tells us, you know, it takes a lot of interpretation. So if we think the road in the middle, we'll use that as reference. So the road's still in the middle. Now we've applied wet area mapping, and now we can see how busy it is and what the wet sites are. So this is, it makes it easy for us to just visually look at it and start to learn about the area. So you can read this, and while wet area mapping predicts wetness, it can also predict dryness. In the current government data set, though, that this isn't an option that's, this would be added value, let's say. This would be something you'd add on. But what a point I want to make here is that just because wet area mapping is there and it shows wetness, surface wetness, don't assume that because that site that's observed is wet, that the site adjacent isn't wet as well. If that makes sense. So what the wetness is showing you, that it's connected to something else, but there could be a wet area next to it as well, and you'll see that in some of my examples. So the challenges, and this may not be the best word, so we'll call it considerations. So considerations that you got to take into account with wet area mapping is that we have, in the province, we have a diverse range of topography, and so we have flat, which is the boreal forest, which we see down in the left-hand corner, very, very flat, you know, less than 1% across large areas. And then we have the Rocky Mountains, the foothills, where we've got a lot of topographical relief. So when UNB created the model, the first model they created was for areas that had some topographical relief and not the typical flat area that we see in the boreal forest. So they developed the second version of the model to kind of fine-tune these flat areas. And so why we want to be aware of that is that when you're using the model and you're using the wet area mapping, you have to think about, it might not be perfect, but it's a very good tool. But you have to, once you start to use it, you're going to start to see things that you might fine-tune, and you might have to actually go on the ground and check or become aware of. So it's just something to consider. So key points about the criteria, and we'll just talk about two of them. And the main one is vegetation. So you have to meet your species on site have to be similar to off-site. So natural recovery, 5,000 stems a hectare. So that's, it was referred to earlier as leaf for natural, LFN. Planted, so two merchantable species and 2 growing seasons. And why this is important, and same for the leaf for natural, is that you have to consider survival. And wet sites, you might get something established, like you might plant a tree, but it might die off after a few years. It's just the wetness, wet and cold, don't always equate to good tree growth and survival. And the second part is drainage. And so on-site conditions, meaning what's on the well pad, have to be similar to off-site. There's lots going on with this site, as you can see. So we'll talk about case study number 1. So everything that, so the ecotopic grid that you see on the right-hand side, that's from Beckingham, and that's from Boreal Forest, so the EcoSites field guide. And so this is really what drives different sites that you have. So you have pine, which would be like an A or B site, which is in the top left, and then you have spruce, rich spruce sites, which might be an E site, which is closer down on the bottom. So that's a moist, rich site. Wet area mapping alone, it doesn't tell you species. And so as we go through this, it's the same area on each side. You can see it with the cut lines and just kind of line it up in your mind. So we don't know anything about species as we look at this. But if you start to combine aerial photos, you can start to see that the wet area up in the top right-hand corner or left-hand corner, I can get this properly. So up in here is this area in here. So now we start to see, well, if we're a photo interpreter, we can look at that map or the photo on the right-hand side. We could start to see, well, what kind of species are there? And just from experience, I know that that area is black spruce. And the area down in the bottom here, this is aspen. And just kind of keep in mind this area right here. So then we apply ABI, and this is not a full-blown ABI. Just for illustration purposes, I truncated the ABI label significantly. But we don't always have ABI, and so this was the edge of an area that had ABI on the left. It's not available on the right, it is, but it gives us a little bit more information. So then we start to combine everything, and we start to see what can we tell about the species on the site. And so this up in here, this is still black spruce, but it's wetter here than it is in here, but it's still black spruce. So the next case study, we'll talk about how are we going to deal with that. Down in here, this is all aspen, and if you were to just look at the ABI label, you would think, well, aspen, that's easy to regenerate. It's a high, dry site, but we see down in here, there's some wet areas that we have to consider. So what is it? What's the application here? Because we want to reduce costs. That's a potential by using wet area mapping. And we want to select the right species for the site. So case number 2, so vegetation establishment. How do we get it established, and how do we consider wet area mapping? So you got to identify the factors that limit growth and establishment on the site. So those are things like heat and moisture excess or lack of. And that's what we'll talk about now. So this is an aspen site. Very straightforward. If you were to look at it, it doesn't really tell you much. A lot of the grayness in the aspen, like you can see in here and up in here and so on, is actually due to forest 10 caterpillar. It's not a function of the conditions of the site. So this is up by Peace River. But then we look at it and we say, there was something. So we go back. You can actually see here, this little leg comes down in here. But to just look at that aspen stand, you couldn't really tell. So you have to apply both of them together. So that wet area that's down in a corner, so we'll go back. So it's down in a corner. It's not going to get a lot of sunlight. It's going to be cold and wet, and it's not going to regenerate well. So you have to do something about that. This area up in here is probably fine, and it'll probably regenerate naturally if you haven't disturbed the site very much, so like an OSE type site. So some options are excavator mounders. So there's only really 2 options if you want to elevate a site and create a high dry site. That's excavator mounding and a ripper plow. And a ripper plow is not like a shank on the back of a D8. It's a big, big plow. The advantages of, in this case, it's choose the most appropriate tactic for the site. You don't have to do blanket treatments. So you don't go onto a site, say, well, the whole site's wet or the whole site's the same. You can fine tune the site, so less soil disturbance. And it's a reduced cost. So I just ballpark $5,000 because it's all over the map. We'll talk about this site, and this is interesting. So this is a site we worked on in the fall. This is the site. So everything in all these sub-sites, this was a experimental area. This is an active gas plant. It's still in, and these are some shops down in here that they're still using. There's no activities, it's just equipment storage type thing. So the black border is an MSL boundary, so it's the area that they were operating in, and all the purple squares or well sites were heavy wells that they were using to extract oil, I guess. So the blue arrows, they show the flow, what I perceive to be the flow of water across the site. But once it gets into the site here, we start to see problems because it's starting to get blocked off. So what actually happened is with this road, this here, it actually started to flow back. And you don't see it now, but there was actually a high point created here, and it actually caused water to flow back and around. So here's the same site, same arrows, same spot. So this was all removed, so we remediated this area in here. Again, this was a high spot. There's actually a lot of ponding water. It was starting to flow out and around. So it's hard to visualize. It's flat. It's very, very flat there. It's less than 1%, and you have this huge site. It's very hard to visualize, and you're standing in 2 feet of snow. Well, where's this water flowing? And it's very hard to run a laser level at that scale, like to shoot hundreds of meters across and start to pick it up. And you're starting to take elevations off the edge of these well sites because each corner has an actual accurate elevation. But the problem is that where you want the water to flow, it doesn't. And you don't want to call in a surveyor to start to establish actual or accurate elevations because it's going to change. You want to direct the flow, and you might not peg it right the first time. So this would have been a great site to have wet area mapping on, and unfortunately we didn't, and we had to spend a lot more time in the field running back and forth trying to establish drainage. So part of the problem too becomes is when you only partially remediate a site, you have to really consider flow then, because you're going to leave roads in place, you're going to leave infrastructure in place, and you want to establish some flow connectivity. You want to create ponds on your site, so it becomes more of a problem when you're only partially remediating. So focus, reduce soil remediation efforts, reduce costs by minimizing soil movement. That means on-site and off-site. And just, maintain connectivity of water courses. So site drainage of inactive. So this is what we typically deal with. A site that's been abandoned, it's done. Somebody's remediated it, it's finished. Great tool, review historic photos. So the one on the left, is as this pad was getting developed. The one on the right, you don't see that water ponding against this road here on this side. But wet area mapping would probably show you that. You want to establish site drainage similar to off-site conditions. So again, when you look at these photos, there's very, very little indicator that there's any streams in this area. But then this is from wet area mapping down on the bottom here. So this is the stream channel that wet area mapping would generate. And so now we start to see how there's actually flow channels that are associated with this site. You'd have a tough time if you're out there in the winter time or even in the late fall of seeing any of these channels. So it's a great tool to see what was there beforehand. So again, it's all, I keep coming back to the soil movement, but it costs a lot of money to move soil, to fill in areas and try to get water to flow different ways. Reduce costs by increasing survival and growth of vegetation. That's an obvious. And then meet reclamation criteria faster. So Jay, I guess, talked about this a little bit before, and this comes back to my experience with the Rainbow pipeline break. So one thing that you can do with wet area mapping is that you can start to focus your remediation efforts. And I saw this firsthand. And so we automatically, when I do anyways, when I look at this photo, I think about this pond here, and it's flowing down this way. And we think about this wet area, and let's say we had a break here. This is a very narrow corridor, but let's say we had a break here and it started to flow down. So, our just first people on site are going to want to go to this area, but when we go and look at wet area mapping, we actually see, so this is where that well site is, so the hypothetical break, let's call it. This is actually probably going to be a problem here as well. You really don't see it here. And when you're in a frantic situation and you're trying to control things, you want to have all the tools available. So this might give somebody a little bit more information. They might put some measures in place so we don't get a lot of flow or movement down here, especially in the springtime. The other thing that, again, this is from real life examples. So old historic spill out in the prairies. So there's no wet area mapping. You'd have to purchase it, get LiDAR flowing, get it developed. But what we found is that we can start to see if you had a historic break back in here, we can actually see that there is a potential that it actually did move off site. And why this would be important is that then we can plan where we're going to do our kind of exploration, kind of to define the boundaries of the spill. So, and then the other thing that I learned too is about these spills along pipelines is that you want to pick appropriate off-site locations for background control samples. And why that's important, if you have a really large site and you've grouped it all together as one sample group, you might have natural occurring levels of certain compounds that might be higher than Tier 1 guidelines. And you want to be aware that they're there. And so in this case, if we look at, it's black spruce here. It's actually black spruce all the way up in here, but you might actually define a little bit better where you're going to take your background samples from and try to approximate it closer to what's on site versus off site as well. Okay, so reduce the area to revegetate and reduce environmental footprint. Weed control. Inside the label of the chemicals that you use for herbicide, or the herbicides, they have restrictions that are associated with water. And so certain compounds, say triclopyr, which is the active ingredient in like release or graze, well, it wouldn't even be in graze on, but some of the active ingredients, you have to be a fair distance back from water courses for you to apply them. So having a wet area mapping detailed against, say, a large area like a pipeline, where you're doing a lot of vegetation control for weeds along it, it's just good proper management so that you can show the spray contractor, here's where there's a wet area, stay away from it with that chemical, or switch your chemical that you're going to use against that water course. I think it's an effective tool to plan and implement activities. It gets us to the criteria faster and cheaper. That's pretty much proven. If you can use it well, that'll happen. Yeah, and it improves soil and water stewardship by considering wet areas and water courses in all phases of remediation and reclamation.